Welcome to this video on box and whisker plots. By the end of this video, you should be able to create a box and whisker plot for a data set using the 5-number summary. You should be able to interpret the shape, center, and spread of a box and whisker plot. And you should be able to answer questions about the quartiles and range and interquartile range of a box and whisker plot. So a box and whisker plot, or box plot, is a way to display data on a number line by organizing it into 4 sections using something called a 5-number summary. Okay, so 4 sections. This is one section, then this 2, 3, and then this last one is 4. Okay, so the 5-number summary is comprised of these values. You have the minimum value. The minimum value is the smallest value. You could also call it the min. The next value is the lower quartile. The lower quartile is the median of the lower half. It could also be called Q1 because it's the first quartile that you'll encounter as you read from left to right. The next value that you need is the median. We have talked about the median previously. You need to put your values in order least to greatest before you find any medians or quartiles, so you can get the correct number. The next value is called our upper quartile. It's like the lower quartile, but it's going to be the median of the upper half. It is often referred to as Q3 because it will be the third quartile that you encounter as you're going from left to right. And then our last value that's important in our 5-number summary is the maximum value. Your maximum value, or the max, is the largest value. Okay, so let's take a look where these happen on our box and whisker plot. So let's go back to our original plot. This lowest point, that's going to be your minimum value. Okay, then your first upright bar, that's the first quartile, that's Q1. That's the lower quartile. It's the first quartile you're going to encounter going left to right. Then the line that's in the middle of the box, that's your median. The third upright, that's your third quartile or your upper quartile. They're the same thing, Q3 or upper quartile. Then all the way out here at the end, that's your maximum value. So you get an idea of the shape and the overall distribution by being able to visualize our data set using this 5-number summary. So these quartiles are pretty important. Because the quartiles are these 4 sections, remember 1, 2, 3, and 4, they represent 25% of the data within each section. So let's take a look what that looks like on our box and whisker plot. So we have this first section, that is 25% of the data. Then we have our second section, which is also 25%. It doesn't matter whether they're wider or narrower. They're still the same number of values within each section. This third section is 25% of the data. And our last, look how wide that is. That just means there's a bigger distance between this number and that number. It doesn't mean that there's more values in there. They're just further apart. Each section has 25% of the data. So if we looked at that as a fraction, each section is 1/4 of the whole. Okay. Now this box, this is your interquartile. Remember that this is your third quartile, your upper quartile, Q3. This is your lower quartile, which is Q1. And it has 2 sections, so it represents 50% of the data, and it's often referred to as the middle 50%. And it's important because it kind of gives you an idea of where the center of the data is kind of going, because half of the data, because we have 2 1/4 sections, half of the data is contained within that box. So it gives you an idea of just kind of where it's at. So your interquartile range, remember we talked about range before, which was your maximum minus your minimum. Your interquartile range is, I want to know the distance between Q3 and Q1. So we're just going to subtract Q3 minus Q1, and that's going to give you your IQR, or interquartile range. Okay, so let's go ahead and give this a try. We have a set of data. So this is the years of experience of 9 teachers. So we want to put these in order, smallest to largest, because we're dealing with medians. And anytime you start talking with medians, you have to have them in order. So our order needs to be 5 years is the least. We have 8, 10, 12, 14, 18, 21, 27, and 30. So there are 9 numbers here, which is an odd number, which means there's an exact middle. So 9, 1, 2, 3, 4, so the 5th number should be the middle. So I'm going to verify this. There's 1, 2, 3, 4 to the left and 1, 2, 3, 4 to the right. I know I'm exactly in the middle. This is my median, just like it was before. Okay, now if you remember our definitions, the lower quartile is the median of the lower half. So I have a lower half now right here. There's 4 values there. That's an even number. That means we're going to have to create the median. The median is going to occur right here because there's 2 numbers to the left and 2 numbers to the right. That's our Q1, or our lower quartile. Halfway between 8 and 10, you can either add 8 and 10, which is 18, divided by 2 is 9, or sometimes you can see it by looking at it that 9 is halfway between 8 and 10. So that's our first quartile. Then we have our upper half. We want to find the median here also. It's going to happen between these 2 numbers, and we can verify that I have 2 numbers to the left and 2 numbers to the right. This is our third quartile, or Q3 is often how we'll write it. And so I want to know what's halfway between 21 and 27. So I can add them. 21 plus 27 is 48, divided by 2 is 24. So that'll be my third quartile. Okay, though we also need to have our minimum or maximum. Those are easy. The minimum is the lowest value, and that's our maximum for our highest value. So let's look. Our minimum value is 5. Our Q1, our lower quartile, is 9. Our median is 14. Our Q3, or our upper quartile, is 24, and our maximum is 30. The last 2 have to do with the ranges. The overall range is just called range, so it'd be 30 minus 5, which is 25. And the IQR is the distance. Remember, we said right up here, it's Q3 minus Q1. So your upper quartile minus your lower quartile. So that'd be 24 minus 9, which is 15. So now we're going to draw this. We need to put a number line underneath it. You always have to have a box and whisker plot on a number line. Otherwise it's meaningless because it doesn't have any structure to it to say what the values mean. So I'm going to start here at 4, and I'm going to count by 2s. So 4, 6, 8, 10. So go ahead and finish that out. So now I have my number line. I can go and put my 5-number summary on here. So remember, looking way up here, the lowest part was our minimum. So we're going to take our minimum, which is 5. 5 occurs between 4 and 6. So I'm going to put a point right there. Okay. Then what came next was Q1, and notice how it has this upright bar, which is your lower quartile, which is at 9, which is halfway between 8 and 10. Then our median is at 14. It also had an upright bar. Our third quartile, or our upper quartile, is at 24, way over here. And then for our maximum, I'm going to put a dot for him too. And we're going to connect Q1, median, and Q3 together to make this box. And then you're going to draw the whiskers out to the maximum and the minimum. And that's your box and whisker plot. So remember, this is your minimum. This is your lower quartile, or Q1. This is your median. This is your upper quartile, or Q3. And that is your maximum value. Between Q1 and Q3 is where you draw the box for the box and whisker plot. Just like with dot plots, you can tell the shape of the data based on the whisker. So remember, when we were talking about skewed left and skewed right, we talked about where the tail is. The same is true here. Notice that this whisker or tail is longer than this right-hand tail. So that longer whisker is on the left. So this is called skewed left. Let's jump over to this one. I have a shorter whisker and then a longer one, or a longer tail on the right. So that's going to be skewed right. And then in the middle, the whiskers are the same, so we're going to call that symmetrical. So if there's a longer whisker, that's the side that we're going to call skewed. And if they're about the same, then we're going to call it symmetrical. So we're going to look at some box and whisker plots. We're going to identify their shape, and we're going to answer some questions on them based off the information from the front. So looking at this box and whisker plot, I notice that this right-hand tail is longer. So that means it's going to be skewed right. Now, let's answer some questions about it. Skewed right. I want to know what percentage of the data is less than 84. So when I come on here, here's 84. So I want to know what percentage of the data is less than 84. Well, there is 1, 2, 3 sections less than 84. And remember, every section is 25%. So that means 75% of the data is less than 84. Because there's 325 sections less than 84. So our last section over here also has 25% because there's a 25% in each section. Now, what value is 25% of the data below? So I want to know what value is 25% of the data below. So here's 25% and it's below this line, which comes in here at 79. So 25% of the data is less than 79. And for our last question, what is the IQR? Remember, the IQR is Q3 minus Q1. It's really what is the range of the box. So Q3 here is 84. Q1 is 79. And 84 minus 79 is 5. So our IQR there is 5. So let's try that again, see how we're doing. Looking at this, these are not exactly the same, but these whiskers or these tails are approximately the same. So we're going to call this symmetrical. Okay. Now, our question, what is the range of the data? Remember, range is overall. So that's maximum minus minimum. Our highest number is 33. Our lowest number is 21. And 33 minus 21 is 12. So we have a range of 12. What value is 50% of the data above? All right, well, remember, each section has 25% of the data. So 100% of the data is above 21 because all 4 sections are above it. 75% of the data is above 25 because above 25 there are 3 sections. 50% of the data is above 28 because there's 2 sections above 28. So 50% of the data is above or greater than 28. And finally, what percent of classes are between 30 and 33 students? So let's look. Here's 30 to 33. That's this one last section. So the answer there is 25%. All right, let's try one last one with that. Now we'll notice that this right-hand tail is much shorter than this left-hand tail. So we're going to call this skewed left. Okay, now let's look. Remember, each section has 25, and even this tiny section, it's still 25% of the data. Each one has the same number of numbers. We saw that when we made the medians too. So 25% in each section. Now I want to know the top 25% of jumps were at least how long? So top 25, so they're talking about the right-hand end. They just want to know about the top 25. So they're talking about this section right here. And they want to know the jumps were at least how long? Well, the lowest number in that top section is, looks like 17. Okay, so 17 feet. The top 25% of jumps is 17 feet or longer. What was the longest jump? So now they're talking about the maximum. So we look, here's our maximum right here. 18 feet was the longest jump. And our final question on this one, the middle 50% of jumps are between what two values? Remember, the middle 50% refers to the box. So they want to know the jumps are between 15 and 17 feet because those are the Q1 and Q3 values. All right, let's do a quick comparison and see how we're doing. So we have a double box and whisker plot. You see this a lot. They're on the same number line, and two sets of data are put here so you can make some comparisons between them. So let's take a look. Let's see, the range of test scores in both classes are the same. Are they exactly the same? So Class A's range is 90 minus 45, which gives it a range of 45. Class B, the highest number is 100 and the lowest is 50, and 100 minus 50 is 50. So they are not exactly the same, so this is a false statement. And we want to know which statement could be true. So let's look at B. Both classes have the same median test score. Remember, the median is the line in the box. So when I look at the box, here's the median and here's the median. Notice how these are not lined up. If they were the same, they would be both lined up over with the same value. So this is a false statement. Exactly half of the students in Class A scored less than the median test score in Class B. Whew, okay, so half of the students in Class A, exactly half of the students in Class A scored less than the median test score in Class B. So if I look, here's Class B's median, and then I follow that up and I take it to Class A, I see there's actually 1, 2, 3 sections in Class A that are below the median of Class B. So that's actually 75%, because remember, each section has 25% in it. So this is a false statement. That means our last one has to be true, but let's look at it and see. It says half of the students in Class B scored higher than 3/4 of the students in Class A. So let's look. So half of the students in Class B would be this information right here. Okay, scored higher than 3/4 of the students in Class B. Well, that's kind of related to what we just talked about. So if I follow this line up, there are 3 sections below. Remember, each one is 25% that are below this median. So that's actually a true statement. Half of these students scored more than 75% of Class A. So this is a true statement. So our answer there will be D. Hopefully that was helpful. I'll see you in class.